Hi, hello students. Welcome to Radiant Tutors and Coaching Center. Atomic structure. This is second video about atomic structure. In the last video, we discussed about what is atom and what are the subatomic particles and how they were discovered. In this class, we're going to discuss about the discovery of a last subatomic particle, that is neutron. And neutrons are discovered based on a different activity, wherein which they have taken a thin sheet of beryllium, and this beryllium sheet was hit with a alpha particles. Alpha particles, as we already know, it has a +2 positive charge, right? As we are hitting the alpha particles with the beryllium sheet, and they found that some particles were come out which are not having any charge. They are having no charge and possessing some mass which is almost equal to the proton. So based on this activity, they could able to find that the third particles, subatomic particles, are present inside the atom, and as they don't have any charge, they are named as neutrons, right? And now the next topic is completely based on the discovery of internal particles, that is subatomic particles, and charge to mass ratio of electron. So this was the first activity to be conducted to understand the characters of subatomic particles, and this was done based on the activity as we discussed in the last class. So what was the activity we discussed in the last class? We call it as cathode ray tube activity. In that activity, when the rays are exposed to a magnetic or an electrical field, they takes a deviation. As it contains electron, obviously they takes a deviation. So based on their deviation, J.J. Thomson, the scientist J.J. Thomson, could able to find the charge to mass ratio of electron is around 1.75 into 10 to the power of 11 coulomb. So this was found by J.J. Thomson, that the charge to mass ratio of electron is this. Now let's try to understand the value of this and what is C. See, by seeing this number, most of the students might get confused and they feel it's tough, but don't feel it is not tough. See here, the value after 1, if you take 11 zeros, the value comes right 175220 and so on. So instead of writing this much value, to make it easy, they are writing this value, right? So please don't take it as a very big number. It's very easy and for our understanding. So what is this? Charge to mass ratio of electron. And later on, based on an activity which is done by a Millikan, they could able to find the charge of the electron. So what is the activity? Millikan oil drop activity. So what is this activity? In this activity also, they have taken a chamber, and this chamber is divided into two halves, right? And the upper chamber is connected to a positive terminal and a lower chamber is connected to a negative terminal, and here one acts as a cathode, another is act as a anode, right? Now he sent some oil. He used a container here and sprayed some oil drops into the chamber, small droplets of oil, and kept a small hole between the two chambers in the middle, right? And he observed them through a observing container here, right? And he observed that the oil drops are slowly falling down into the cathode. So please assume here, as we are connected with a electrical field, So here it acts as a cathode and here it acts as a anode. So cathode rays are transferred or move from cathode to anode, right? So we can't see the electrons, but we can see the oil drop. So by checking the speed of the oil drop, they could able to find the charge of the electron. So you understood, I think. So what he has done, he has taken oil and it's sprinkled, and the sprinkled oil is sent to the anode, and that is observed through another chamber, right? And in which they observe the speed of a oil drop that is coming down, right? And they could able to find the charge of the electron. So they find the charge of the electron is around 1.62 into 10 to the power of minus 90 coulombs, right? Okay, good. So we got the charge of a electron and we know the charge to mass ratio of a electron, right? Now by taking these two values, we can find the mass of the electron. So what is the mass of the electron? So mass is considered by mass of electron is taken as, it is the ratio of charge to mass ratio by the mass. So what is charge to mass ratio? 1.75 into 10 to the power of minus 11 by what is the charge? 1.62 into 10 to the power of minus 90, right? So with this, they got the value of the overall 9.109 into 10 to the power of minus 31 kgs. So this is the mass of electron. So based on these activities and observation, they could be able to find the charge to mass ratio of an electron, charge of an electron, and mass of an electron. So with this, we complete the properties of the electron. And as proton is having a same and opposite charge, same value with a opposite charge. Suppose here if you take the charge of an electron is minus, and proton is also having the same value of a with a positive charge, plus 1.62 into 10 to the power of minus 90. So this is the reason why atom is neutral. So how many protons are present inside the atom? That many number of electrons are also present inside the atom. So that was explained in a different way. Let's see this. So if you take any atom, right, based on the number of electrons and protons, scientists could able to give the some terminology. The first one is atomic number. Atomic number. So what is atomic number? To say simply, it is the number of electrons of a neutral atom. The first one is, it is the number of electrons of a neutral atom, or number of neutrons, number of protons, number of electrons of a neutral atom, number of protons of a normal atom. We need not to consider a neutron or normal, because if you take any atom, as we already know, nucleus contains a positive dense and electrons are revolving around the nucleus, right, in a fixed path called orbits. We know this, right? And if you remove one electron from outside, from the outermost shell, right, there is a tendency of the element will get a positive charge. If I say the number of electrons for the positive charged atom, we cannot say it is as a number of electrons or atomic number. That's why I am specifically mentioning here that the number of electrons of a neutral atom or a number of protons. Obviously, protons are inside the atom, so inside the nucleus they cannot be taken out. Okay, so and the next definition that is given here is atomic mass. What is atomic mass? So atomic mass is nothing but it is number of electrons of a neutral atom plus number of neutrons, or or can also be defined as number of protons plus number of neutrons, right? So by knowing the atomic number and mass number of any atom, we can say the number of protons and number of neutrons and number of electrons of a given atom. For example, to understand, I am taking oxygen is an element, right? It has an atomic number of 8 and mass number of 16. So please remember, atomic number is always mentioned as a subscript at the left bottom, right? And atomic mass as mentioned on the top as a superscript as mentioned here, right? And even in some textbook, oxygen is shown like this, means right top it is shown, and in some textbook it is shown in the left top. Both are correct representations, right? But atomic number should be mentioned at the bottom. Okay, now atomic number is mentioned here, mass number is mentioned here, right? So what I told you, atomic number is the number of electrons or number of protons, right? So as it is a neutral atom, we can say the number of electrons are 8 and protons are also same, so the number of protons are also same, that is 8. And how we'll find the number of neutrons? Here a different formula, A minus Z. So what is A? A is denoted with atomic mass is denoted with A, and atomic number is denoted with symbol Z. So what is the value here? What is A value here? 16 minus 8, that is 8. So number of neutrons are 8. So by knowing the atomic number and mass number of an element, we could able to find the number of electrons, number of protons, as well as number of neutrons. So don't think that the atomic number, if we double, we'll get the mass number. It's not same for all. For example, if you take sodium, sodium is having a different values. Sodium have atomic number 11, mass number 23. So if you take the number of electrons are 11, right? Number of protons are also 11, same number, no change, right? When it comes to the number of neutrons, as the formula applies, A minus Z, A mass number 23 minus Z, that is 11, right? So what is the value comes here? 12. So for sodium, it is number of electrons 11, number of protons 11, number of neutrons are 12, right? Okay. So with this we complete the next topic of atomic structure. Now we discuss about atomic models. So in the previous classes, you might be heard about a basic model of atomic structure. So in a basic model, what we studied first is a J.J. Thomson model. So the model atomic So what are the different atomic models? The first model is J.J. Thomson model. As you already know, it is based on just assumption, not a theory or not an any activity. So he gave a model in which atom is spherical in size. This is correct, what he gave, right? And it is fully filled with a positive matter. It's completely filled with a positive matter, right? And electrons are just embedded in this positive matter here and there, right? So this was the assumed model of a J.J. Thomson, right? So it's almost resembling like a watermelon, right? So the positive matter is resembling like a red matter of a watermelon, and the seeds are resembling like the electrons, right? So as it is resembling the watermelon, this model is also called as watermelon model. And the next model is Rutherford model. Rutherford model of an atom. So in which he gave this this model based on an activity, we call it as alpha ray scattering activity or experiment, right? So what is this activity? So it has taken a very thin foil of a gold. So this is a gold foil, and this gold foil was hit with a alpha rays, with a alpha rays, and kept a detector around it to find the changes which are happening in it, right? So once he hit with the alpha rays which are having a positive charge, +2 charge, he hit with the alpha rays, right? He gave a theory based on his observation, right? So what was the first observation? That most of the rays are passed through gold foil. Most of the rays could able to pass through the gold foil and detected on the opposite side of the screen, right? Okay, next, some rays were taken a deviation and detected at a different angle. They taken a deviation and detected at a different angle, and 1 out of 20,000 rays were bounced exactly at 180 degrees. So these are the three observations. So what are the three observations? First observation is most of the rays could able to pass through the gold foil, right? Very few rays were taken a deviation at a different angles, right? 1 out of 20,000 rays were exactly bounced back at 180 degrees. So these are the observations. So based on this observation, what he has done, he gave some results. So what the results say? He gave a model completely contrast to J.J. Thomson model, right? So what he gave observations that most of the space inside the atom is empty. He found that. So what the results he gave? First observation is most of the space in atom is empty. Suppose, assume, if you are standing in front of a fence, iron fence, if you have some stones in your hand, if you throw them, what happens? Most of the rays could able to pass through the fence, and very few were touching the fence and falling at a different direction. 1 out of many stones may be coming into the opposite side or to our side, right? So why this is happening? Because there is a most space is empty. So the same thing happening here. That is why most of the space is in the atom is empty. That's why the rays could able to pass through the foil, and the rays which are hitting at the nucleus exactly. This is the atom. If the rays were hitting at the nucleus at a different angle, were taken a deviation. They were taken a deviation and detected at a different angle in the detector, right? And the rays which are hitting at exactly at the middle of the nucleus were bounced back. So the first observation is most of the space inside the atom is empty, and second one is electrons are revolving around the nucleus. Electrons are revolving around the nucleus in a fixed path called orbit, right? So these are the results that were given by Rutherford based on his activity. With this, we complete the today's video, and we continue the remaining models and the remaining topic of atomic structure in the next video. If you like the video, please like, share, subscribe to Radiant Tuitions and Coaching Center. Thank you, students.